Ma'am, please start.
Okay, thank you, ma'am. So again, we welcome you all to this afternoon session. So today with us, Dr. Amit Kumar Jha, Assistant Professor. He is working at College of Veterinary Sciences and Animal Husbandry, Riva, and he was a product of Assam Agriculture University, Jorhat, and he has awarded masters and PhD from JNKVV Jabalpur and NDVSU Jabalpur in 2010 and 2015 respectively. He also served as animal husbandry officer in Department of Animal Husbandry, Government of Bihar. He has guided four postgraduate students and published more than 40 research papers and review papers and 70 extension article, including books chapters 25. So, and he is recipient of many awards, namely Young Scientist, Best Paper, and Best Poster Award. Presently, he is also handling research projects funded by Madhya Pradesh State Biodiversity Board, Bhopal. So, sir, we welcome you from the organizing team, and you just share your lecture on statistical method for biological and social sciences data. So, over to you, Doctor.
Thank you, ma'am. I've been very much thankful to all the organizers, Atari, June 1, then RVS, KVB, and NADCL for making me a part of this 21 days national orientation course on teaching, learning, evaluation, and technology program. So thank you once again. Now I will start my presentation. And the presentation is a statistical methods for biological and social sciences data. As this statistical method is a very vast topic, vast subject, in fact, and we cannot complete it within 1 hour. So that's why I have tried my best to touch uh, all the essentials of the biostatistics, obviously, and so that we can have a knowledge of these things. I think most of the participants who are here might be aware of these methods also, but still there may be some who may not have idea about all this. I think they will certainly gain something about this. So the first, let's start with the statistics. It's the information contained in a data is a vital aid in scientific decision making. And we know very well because the data are there, but what the data is containing in form of information, that is vital, and without which we cannot have a scientific decision. And so if we think of this, then data is like water. As we know that water is very much vital to our lives. We cannot survive without it. But we cannot take too much of water. If too much pours over us, we drown. So to keep from drowning data, we must learn use it properly. Simply means as the water is essential for us, but too much is will definitely be harmful for us. So we must know judiciously how to use that. In the same way, we must learn use properly the data, and we must find the means figuring out what the data is telling us. So it's the data itself we use to make a decision. It is the knowledge within the data that we use. And that's why we must learn how to analyze data. So in brief, if we say that statistics is nothing but it is a branch of science which deals with collection, tabulation, classification, analysis, and interpretation of the data. Next, the statistics is used for a study of populations, study of variations, and a study of methods of reduction of data. A study of populations means population can be defined in many ways, but for a statistical term, it's a large group of data. It's a very large data, and since it is a data, then and pertaining to a particular field, pertaining to a particular trait, so what those populations says, we will be studying through statistics. And if the data is there, and that through biological data or any data, it will have some variations because it is impossible to have a data without variation. So if we have to study the variations, then also we will have to use statistics. And statistics is also used in the methods for reduction of data, because data as such is a very large cumbersome. So to have a meaningful idea of that, we must have a reduced data. And there are some statistical terms which we should know, and these are population parameters, sample size, variable, estimator, test, it's statistical. So again, we already know that what is population, and the population parameter means, say, the mean of the population, variance of the population. Variance means the variability within the population, variability within the data, and these are called the population parameter. And sample means the representatives of a population. If it is a true representative of the population, then it is called a sample. And of course, the sample size, what should be the sample size so that it gives the meaningful result of that particular population. And the variable is it takes the values, an estimator which is used for estimating the different statistics. And the test, there are certain tests of significance which are used. Herein, the individuals, if we talk, then individuals are the objects are described by a set of data. For example, here the employee, lab mice, etc. So these are called individuals, and variable, it is a characteristic of an individual, and that is of interest to the researcher. For example, if we are interested in finding about the characteristic of an individual pertaining to his or her age, then in this case the age becomes variable. Sometimes if we are working on the salary, then its salary becomes variable. So weight location, there are many things which, if it is a characteristic of an individual and which is of interest, then it becomes a variable. Now look the measurements. As we know that this is a very common word, common term which we generally encounter, that it is the value of a variable obtained and recorded on an individual. So one thing which one should keep in mind is that when an individual, if a variable is recorded and obtained, it is called measurement. And but when a sets of measurements are made on a group of individuals, then it becomes a data. And its distribution of variables tells us that what values it takes and how often it takes these values. So measurement, data, and distribution. Now, once we are having the data, then if we go for analysis of data, then we must have two things. First is the descriptive statistics and inferential statistics. Descriptive statistic means it's just provide an attribute of a data set. For example, the measurements of central tendency and the dispersion. So frequency, histogram, mean, median, mode, these are the measurements of a central tendency, whereas the range, variance, standard deviation are called dispersion. We will discuss a little bit about them in the coming slides. And inferential statistics means suppose we are conducting an experiment and we have hypothesized. So how our data support our hypothesis, and if these data are generalized beyond what was tested, this is called inferential statistics. As it is very much clear from the name itself that we want to infer. So statistics pertaining to inference is called inferential statistics. Now, type of statistical analysis. So what type of statistical analysis are there? That what data analysis we will be doing, that depends upon various factors. And the first of them is the number of population. Say if we are working on a single population or two or more than two, so here the number of population is also one of the factor or where the data analysis will depend. So similarly, number of variables, type of variables, parameters, sample size, and of course assumptions. So type of variables may be different: nominal, ordinal, interval, ratios, and parameters. mean, variance, median. So these are the different factors on which data analysis depends. Coming to the data type, say, as we have learned that it is a variable, so there are two types of variable, scale and categorical. If we talk of the categorical, again we have the ordinal and nominal. Nominal means there will be no meaningful order. Whereas in case of ordinal, obvious order is there, first, second, third, fourth, fifth, like that. It will be in order. And discrete, here we say that it is a count or integer. Means it cannot be divided. Whereas it is a continuous, then measurements, and it can take any value. Well, for example, uh, body weight, milk production, or irrigation of agriculture, it is the wheat production. So it can take any values on a scale. That's why it is called continuous. And whereas a discrete means it is a count and integer. For example, if you talk about the number of kids born in a goat farm, then obviously it would be a integer 1, 2, 3, 4 like that. We cannot divide that 1.2, 3.5 or like that. So this is called a discrete type of variable. And ordinal 1, 2, 3, and nominal means it is pronounced and it will not have any order. Now, descriptive statistics. As we have discussed a while ago, that descriptive statistics are used to report on the populations and sample. In sociology, summary description of measurements, that is the variables taken about a group of people. And so summarizing information or descriptive statistics, what does it do? It speed up and simplify comprehensions of a group's characteristics. Say, if you have a data of 100 students, so pertaining to body weight, then what this data says, what is the variation, what is the lowest, what is the largest. So these are the informations that will be summarized through descriptive statistics. That since it describes, that's why it is known as descriptive statistics. For example, central tendency, our group, it is called middle values, mean, median, mode. These are the central tendencies. And whereas variation or summary of differences within groups is done through range, interquartile range, variance, and a standard deviation. If we talk about the mean, it is the most commonly called the average or arithmetic mean, we know very well. And it is simply obtained by summing all the numbers, but their values and dividing by the total number of objects or dividing by their total numbers. But it can be badly affected by the outliers. So what is outliers? When we are having a data sets, then there are some extreme values. For example, if we talk about, say, the uh, marks obtained by students in a particular class, then the most of the students will say if it is average class, then say 50 to 60%, like that. But there may be some students who might be scoring 100, 98, or like that, and some may 2 or 3. So these with extreme values, unlike the rest, are called outliers. And what the important thing to be kept in mind is here is that outliers make the mean a bad measure of central tendency or common experience. For example, if we are having a data set of say 100, and if we are excluding that the 99, then the mean of the data, and on the inclusion of that there will be huge difference. So that's why it is mean is the bad measure once outlier is there. Next, coming to the median, this is the middle value. When a variable's values are ranked in order, order is in ascending or descending order. Say we are having a data set of 10, and if we have to find out the median values, then what we do, we just arrange it either ascending or descending. Then the middle value, which divides this order into two equal halves, is called the median. So the median is the point at which 50% of the cases are above and 50% below it. For instance, in this case, look, a group A is there where blood pressure of 30% are there. So what we have done here, we have arranged it in a ascending order. So what we find that 6 cases above and 6 cases below is there. So the value is 109. So this value 109 is the median of this data. And one of the important thing which is to be noted here is that unlike the mean, the median is not affected by the outlier. For example, say instead of 140, if it would have been 1 lakh also, then also the median would have been the same, that is 109. But here in this case, in case of mean, if 1 lakh would be there, then the mean would be entirely changed. So that's why mean is most affected by the outliers, and it is unaffected by the median is unaffected by outliers, making it a better measure of central tendency and better describing the typical person than the mean when data are skewed. Look, if the recorded values for a variable form a symmetry distribution, if a distribution can be called as a symmetry distribution when it is having a bell-shaped curve. So, as we are seeing in this slide, the left one is a symmetrical distribution where the mean and median are identical. Whereas in the skewed data means when the distribution is not symmetry, the mean lies further towards the skewed data than the median. And now coming to the mode. The most common data point is called the mode. Say here also the glucose level for a group. What we see means a number can be a variable if it is a data is represented. So the data which is represented or which is having highest frequency will be regarded as a mode. In this case, if you see, then what we find that it is the 109 that has been repeated thrice. So since it has got the highest frequency, that's why it is called the mode of the group. And here also, in case of a symmetric distribution, what we find that the mean, median, and mode are the same in case of symmetric distributions. And but in skewed data, you find the order. It is the mean is towards the skewed, then comes the median, and on the left side is the mode. So these are the properties which we must remember. Now the summary statistics means which average and measure of a spread is there. One is categorical. If it is a categorical, then it is ordinal and nominal. Nominal, then mode, it and median interquartile range. And if it is skewed data, then it is the median and interquartile range. And if it is a normally distribution data, then it is the mean and a standard deviation which we use. So a standard deviation is used for the measure of a spread if it is a normally distributed. If it is a skewed data, then interquartile range is used. And for categorical also, if it is ordinal data, then the interquartile range is used. So before moving to this, let me clear one thing more, that what is the central tendency and what is dispersion? Why do we measure a central tendency and go for measuring dispersion? You know, the central tendency means it is the tendency of a data to move around or to keep around themselves around a central value. For example, if their data set of thousands are there, then there must be an average value through which the other values are there. So that central value is the mean value. So that central value is the mean value. This mean value can be mean, median, mode. So this is called measures of central tendency. And it is very much important. If we are having thousands of data, and if we have to say something about the data, we cannot go for just naming all the data. We have to compare, say we have to compare 4 groups or 5 groups. Without going much in statistics, if you have to say that which class is the best in relation to a particular subject, then of course we will go for finding the mean, finding the average, and one who is having the highest mean or highest average will be selected. What does it mean? It simply means that we must have a measure to find have a central value. So this is called the measure of a central tendency. Now the measures of dispersion. Look, there may be two class where the average of the subjects, average of the marks of the subject may be the same. For example, the 20 out of 25 students, if we calculate the average for a particular subject, then also they may having the same 70 marks. And in other groups also, other class also, they may be having the 70 marks. But does it mean that all the data for which on which we have applied the this arithmetic mean or average is the same? Though it appears that since the mean of the both the classes in relation to a particular subject is same, so the students of the both the class are equally good. But it appears, but it may not be. Say the variation between the data, variation between the marks, if it is maybe from 10 to 100 or maybe 50 to 60. So all the data may be ranging from 50 to 60 in a particular class, or maybe from 10 to 80 also. So here the point is that since they have got the same average marks doesn't mean that they are equally good. So what mean is to find out the central value, but how far the other values are scattered from the central value, we must have measures. And those measures are called the measures of dispersion. And for to find out the variation, we need to have the measures of dispersion. And for that, the first measure of dispersion is the range. And it is the spread or the distance between the lowest and the highest value of the variable. So here, say, if we talk about the class A and IQs of the 13 students, so the range is 140, 89, it is 51. But in class B, the range is 160 minus 80, because in this case we took the highest value minus the lowest, and the difference is the range. Now interquartile range. A quartile is the value that marks one of the division that breaks a series of values into four equal parts. And it is the median is a quartile, and that divides the cases in the half. If you talk about the 25th percentile, 75th percentile, so it means it divides and the first three quarter in case of 75th of fifth percentile, and 25th percentile in case of 1/4 of the cases from the latter 1/4. So the interquartile range is the distance or a range between the 25th percentile and 75th percentile. So this is how this is made. Now variance. As I have just now spoken, that it is the spread of the recorded values on a variable is measured through a measure of dispersion. So variance is one of the measures of dispersion, and the larger the variance, the further the individual cases are from the mean. For example, if in a farm there are say 25 cows are there, and one cow is producing 5 kg of milk, 5 liter of milk per day, and there may be some other cows having the highest milk producing ability and may produce 25 kg. So, and the other farm is there where all the cows are producing 10 to 12 kg milk per day. So if we talk about the variation, then what we find that in the first farm, that the variation is more, because it ranges from say 3 4 kg to 25 kg. But in case of second farm, all the average milk production is around 10 to 12 kg or liter per day. So if the variation is large, so of course the variance will be more. So if variance is more, means the individual cases are far from the mean, and smaller the variance means closer the individual's scores are to the mean. Now, box plot. Box plot, we might have heard this box plot so many times. Actually, it is a way to graphically portray almost all the descriptive statistics at once, and this is the box plot, wherein we find the upper and lower quartiles, mean, median, range, and outliers. So these are the box plot where we can find out all the descriptive statistics at once. Now coming to the normal curve, look, as we have discussed, normal curve means a symmetric curve. So it must have some characteristics. So based on which we can say this is a normal curve. So 50% of the scores fall above the mean and 50% fall below the mean. So then only it will have a bell-shaped or symmetrical. And here the mean, median, mode are the same values. And the most participant scored near the mean. Further the score is from the mean, the fewer the number of participants who attain that score. And the specific number or percentage of a score fall between plus minus 1 standard deviation, plus minus 2 standard deviation, etc. Here, the point is that as the distribution is symmetrical, the half of the data fall below the mean and half of the data above the mean. And in the case of normal curve or this distribution, the mean, median, and mode are the same. Whereas in skewed distribution, skewed means when this is not symmetrical. So it may be a positively skewed or negatively skewed. When it is a positively skewed, then it is many low scores and few high scores are there. That's why it is called positive scores. And negative means a few low scores and many high scores. So relationship between the mean, median, and mode in case of positively skewed is that the mode is lowest, median is in the middle, and the mean is the highest. Negatively skewed, mean is the lowest, and median is in the middle, and mode is the highest. So this is one of the important features which we should remember, that for skewed distribution, the relationship between these mean, median, mode is different in case of positively and negatively skewed distribution. Whereas in case of normal distribution or symmetrical distribution, it is the mean, median, mode which are the same, which coincide at the same. Now, moving ahead, once we are having a data, once we have uh, information about their descriptive statistics, we know about what's their mean, median, mode, and what are the variations among them. So now if you want to conduct an experiment, so for conducting an experiment, we must have some test, statistical test, which allows us to arrive at a decision in an objective manner. There, in an objective manner means there must be some decision, inference, that whether it is right or wrong, whether it should be taken or not. It should not be subjective. So statistical tests are used for testing claims or comparing two groups. So taste would vary and it will be based on population parameter, that mean, proportion, variance, and the number of groups also. So for that, if we have to conduct an experiment, then first we hypothesize. So that hypothesize means which we call the hypothesis. And this statistical hypothesis is a statement about a population. So there are two types of hypothesis: null hypothesis and alternate hypothesis. And it depends on the research hypothesis. Null hypothesis and the complement and alternate hypothesis is a research hypothesis. So as it is evident that null hypothesis means no difference. Say we are having two sets of data from a farm, but maybe it's say wool farm, where we have to find that the two samples which we are having, they are from the same form or they don't differ significantly. So for that, we have to make a hypothesis. First, that these samples or these two samples doesn't differ significantly. And so such hypothesis is called hypothesis of no difference, and this is called null hypothesis. So null hypothesis is to be tested for possible rejection. Means it is only what we have hypothesized. It is not which we have that proved it. It may be rejected, it may be accepted. So once first if it is rejected, then the other hypothesis that is accepted is alternate hypothesis, and which means it says that there is difference between these two data. So alternate hypothesis, again, in null hypothesis, what we have hypothesized that these two sample groups don't differ significantly. But in alternate hypothesis, if the null hypothesis is rejected, then we are in position to accept the alternate hypothesis, wherein three types are made there. Either the sample A may be greater than the sample B, mean, or maybe less than or not equal to. So if it is, if we are able to find that this is not equal to, it may be greater or maybe lesser, then it is called two-tailed test. And when it is less than, then it is called left tail, and when it is greater than, it is called right tail. Again, when we are hypothesizing or when we are going for applying a statistical test, of course we are going to commit some errors, and these are known as type 1 and type 2 errors. Whenever we are going to conduct an experiment, it cannot be foolproof. There will be some error. So ideally, this type 1 and type 2 errors are committed, but these should be zero or minimized. But in experiment, it is not possible to make it zero or minimize both of them. So usually type 1 error is fixed and type 2 error is minimized. Now we will discuss what is type 1 error and type 2 error. Once we have hypothesized and the null hypothesis is rejected, but when it is true, means when we have said that there is a difference, there is no difference between sample A and sample B, but we have rejected it. Means we have rejected. How we have rejected? We have rejected, say, through statistical test. But once we have rejected it, when null hypothesis was true, then this is a case of type 1 error. And the type 2 error is that when null hypothesis is false, means this there was a difference, but we have accepted it. So this is called type 2 error, and that one is type error. We should mind that the type 2 error is more dangerous. To reject null hypothesis when it is actually true, it is called type 1 error. So this is these are used in diagnostics, guilty versus not guilty. Like that. Now here also the significance level is probability of committing a type 1 error is called significance level, and where we reject, and alpha is usually fixed at very small levels such as 5% or 1%. These are called the significance level at which this type 1 error is tested, and the p-value is there, and which indicates how incompatible the data are with the specified statistical model. In actual, p-values don't measure the probability unless the hypothesis is true or the probability that the data were produced by random chance alone. So now if we have to go for a hypothesis testing, then what we do, first we define our study questions. Then we set a null and alternate hypothesis. Then we go for a calculating a test statistic. We go and calculate the next step of p-value and make a decision and interpret your conclusion. So these are the steps for a hypothesis testing. So then only we go for choosing a suitable test. So, in many of the research paper, we might have come across these notations: p is greater than 0.05, lesser than 0.05, and having a no star, single, double, triple stars. What is it in for? It means if a p is greater than 0.05, it means the null hypothesis is accepted. And if one star is there, then it is called significant. In case of null hypothesis is rejected in all the three circumstances when the p-value is lesser than 0.05, 0.1, 0.001. Actually, the level of significance is tested at 95% and 99%. So in this case, when the p-value is smaller than 0.05, 0.01, and 0.001, then these are rejected. Now, in terms of a strength of association, the bivariate summary statistics is that first is correlation and regression, as we know. Correlation coefficient. Correlation is measured by correlation coefficient. So, what is correlation? It is a linear relationship between the two variables. For example, body weight and height. So, these are the two variables which are linearly related. If the body height is more, if the height of an individual is more, then of course the body weight will be more. So, and these, the correlations, the measures of associations is measured through correlation coefficient, and it ranges from -1 to +1 through 0. For example, -1 and +1 means they are positively perfectly correlated, and minus means negatively perfectly correlated. For example, if we have a higher milk production, then the total fat yield will increase. So this is a positive correlation. But if the milk production goes up, then the milk fat percentage will go down. So this is negatively correlated. And there are some correlation which that doesn't exist any such correlation between them. So this is called such type of correlation between the variables are called nonsense correlation. For example, height of the individual and their IQ level. There is no correlation as such. So this is how this correlation is computed, and this is the regression. A regression coefficient here the relationship between the two variables, the relationship between the two variables, if it is a linear, then it is called correlation. But if it is a functional relationship between the two variables, it is called the regression. And the regression is calculated by regression coefficient, whereas the correlation between the two variables is calculated by correlation coefficient. Now, as we have heard that there are some statistical tests. So first, if you go for a test, then large sample tests are there. So when suppose if you are working on a sample size which is more than 30, and if you have to work on, then we go for large sample test. And for this test, jet test is used. Then if the sample size is less than 30, then we go for a t-test. We will do some, I will show you through SPSS how this single, double, and pair t-test, independent t-test, and ANOVA is worked out. So this is the t-tree distribution. Now, this is a sample calculate for how we calculate the t-values for two population means. This is the t-star pair test. So before starting that, there are some tests of significance and known as JAD test, t-test. Again, t-tests are of three types: single mean t-test, independent t-test, pair t-test, chi-square test, and f-test. So now one of the important thing that sometimes we get confused that which test to be used in which case, how these tests are to be used. So if we are to compare the means, then the JAD test and t-tests are used. JAD test and t-tests are used. Z test, when we will use that, use Z test when the number of samples are more than 30, and we go for using this Z test. For how we will use, there are softwares and even the formulas are there. No need to worry about that. But we must know that if we are to work on samples wherein we are to compare the means between the samples and the population, then we go for a Z test. But if the sample size is less than 30, then we go for t-test. T-test was given by a scientist, Gossett. Actually, t-test is it doesn't have any name. Actually, it is called a student t-test. It was the pen name of FS Gossett. So if we are to test the mean, then we are having two types of a statistical test. First is z-test and t-test. Again, when the number of samples are more than 30, then we go for z-test. But when it is less than 30, then we go for t-test. And t-tests are again of three types: single mean t-test, independent test, and pair t-test. Single mean t-test means when we have some samples, then if we calculate the mean, and if this mean are to be compared with the population mean, which we will be provided or which we are having, then this is called single mean t-test. Then another is independent t-test, means we will be having two sets of observation. If we uh, take an example, say in a farm, there may be buffalo and cattle. So number of buffalo calves born, say 10, and the cattle calf maybe 10 also. So if we have to find out whether the mean body weight of the buffalo calves and the mean body weight of this cattle calves, there is a difference between them at the birth weight or not. So since these two samples which we are having are independent, so we will go for independent test. We will go for independent test. And after having the test, then we can find out whether they are significantly differ from each other or not. That depends upon the t statistics and the value, whether t calculated is greater than uh, t tabulated value or not. But another test is pair t test. Here, look, this is the most confusing test of significance is due to this test. When to use pair t-test, when to use independent t-test. Pair t-test is used whenever the two populations are related. Generally used when the measurements are taken from same subjects or units before and after administering some treatment or drug, etc. For example, say we are having 20 individuals and we want to see the effect of a particular medicine on the blood pressure. So what we have to do that whether this medication for blood pressure is effective or not, so that we have to test. But how could we test? We have two sets of data. First, the blood pressure, the observation of the blood pressure before taking the medicine and after the medicine. Means the subjects are the same. Means the individuals are the same. We are having two sets of observations from the same sample or from the same subject. So now this is called paired t-test. Means we are having a paired observations on the subjects. There may be some other examples also. For example, say if you have to find out, say, serum glucose or some other blood or serum parameters, if you have to find out. Now there may be two different methods of finding those two means. So whether these two ways or two methods, which the scientists are claiming that their method is the best. So to find out what we do, what we are having a same blood, and we are first doing calculating the serum parameters from one way and the other time the other way. So again we are having a two sets of observation from the same. So this is called the paired t-test. Look, the same thing which I have told. Now this is the test statistics, how we calculate the t-test. Now there are some assumptions also that samples must be chosen randomly, the data must be quantitative for doing t-test. Data should follow normal distribution and the size is ideally less than 30 in each group. Yes. Now, so I think one thing is very much clear that if we have to compare the means, then we will go for the Z test and P test. Again, here Z test, if the sample size is more than 30, then we will go for Z test. If it is less than 30, then P test will be there. But if we have to find out, if we have to go for a testing some distributions, then in that case, what test we will be using? So for that, chi-square test is used. Chi-square test is a statistical test which is used to determine whether your experimentally observed results are inconsistent with your hypothesis or not. Means actual counts and expected counts, and it is a non-parametric test. Look, the parametric test and non-parametric test differs in the simple way that the data which is having a symmetrical distribution or a normal distribution or which are normally distributed, and the statistical test which acts on them is called the parametric test, like t test, z test, f test. These are parametric tests, whereas chi-square test, even if some of the data are there and which are not normally distributed, and even then if we have to work with that, then we will go for a test that is called chi-square test, and it is a non-parametric test. So there are some assumptions here also that in general and mean sample size should be more than 20, and the number of observations, observed frequency should never be zero. Its frequency, expected frequency should not be less than 5. So this is how the correct chi-square test statistics are compared. Now look, what I have just telling you about is that if you have to compare the means, so comparing mean between groups and comparing measurement within the same subject. If we are comparing mean between two groups, so if we are comparing between two groups, then independent t-test used. But if it is more than 2 3 plus, then one way ANOVA is used. But comparing measurement within the same subject, and if it is the comparison is among between the two, then we are going for a paired t-test, whereas the repeated measures ANOVA is used in case of the comparisons within the same subjects. So this is I have presented it. Look, the if t-test, when we will using t-test, when we will using a chi-square test. Say if it is a chi-square test, if the two categorical values are there, the scale variable are there, then we will go for Pearson correlation, simple linear regression, and the logistic regression used for predicting the value of dependent variable from the value of independent. Now coming to the principles of experiments, when we are going to conduct an experiment, then we cannot conduct it haphazardly because the results should be such that it can be generalized. So for that, there are some principles, and that is called randomization, replication, and local control. Randomization never means that haphazardly. Randomization means the random, the experimental units are allotted to treatment, or treatments are allotted to experiments randomly. Randomly means they have got equal chances, and the replication to have the more precise the result, the replication is used, and for this a local control is used. So designs of experiment, there are some treatments, factor level, experimental units, observable. These are the terms. Treatment means, say, if you have to compare the four fertilizer groups or four fertilizer, different types of fertilizers on crop yield. So these four fertilizers are called treatments. If you are using a medicine, then this is called medicine. If you are working on the different types of feed, and we want to find out the effect of these feeds on the milk production or body weight, then these are called the treatments. And the factors and levels are different under the treatment. Experimental units means on which we are conducting the experiment. Say, if you are working on crops, then the crop will be experimental unit. If you are working on animals, then the animals will be the experimental unit. If you are conducting on humans, then humans are the experimental unit. And the observational units are almost the same. So experimental units, a piece of experimental material to which treatment is assigned and applied. This is called the experimental units. And the examples are experimental plot, patients, tree. So all these are. An observational unit is the unit on which observation or measurements are made. I told you earlier that experimental units and observational units may be same for us entire field for yield or sample of plants for plant heights. Now treatment that I have already discussed that single factor, more than one factor is there. If it is more than one factor, then the factorial structure is there, three levels like that. And experimental units, no differences between experimental units other than the treatments be applied. And blocking means removes differences by ungrouping similar units within a block. And the randomization we used to do to take care of any uncontrolled variation among the experimental units. So after this, we used to go for analysis of variance. ANOVA. And here what we do, there are some causes that is called the assignable causes, that is variation due to treatment, variation due to experimental materials. So suppose if you have to see the effect of say a particular feed on milk production, so in this case the treatment is the feed and the production is which is affecting is the milk. So the assignable cause means which we can see that it is the due to particular this treatment, this is called assignable cause. But all the unassignable cause, because while conducting an experiment there are certain errors which will creep in and which we don't have any control over them, so those are called errors. So when the variation is there, say response here in this case is that say increase in milk production or milk production. So it will be the effect of treatment and the error also there. ANOVA under null hypothesis, what means that all the treatments are equal. But if the large F value, it means treatments are different and null hypothesis is. What are the assumptions in ANOVA? Errors are independent and errors have constant variance and errors are normally distributed. The guidelines for experiment is that identify experimental units and observational units, identify any other factors which may affect response, that these are called covariates, and measures should be taken at the same for all units or at least for one application at a time to avoid day-to-day variation. And we will go for some like SPSS we will using for finding out the independent, how we do independent test, t-test, pair t-test, one-way ANOVA, that we will be doing. So first let me the screen is visible.
Yes, yes,
Hello.
yes, it is visible.
Okay. So this is SPSS. This is a software statistical package where we will find that how the independent t-test, pair t-test, and one-way ANOVA is calculated. Look, what we see that there are, if we see that there are two things here, data view and variable view. When you will open this window, that is the SPSS, then this is the things which we will be having with us. First is data view and variable view. If you will click the variable view, then you look the name, type, width here, where we define the variable. And after defining the variable, we go for data view. But since I have already defined, so I will show you how it is done. Now, again, there are things that say we can just enter the data, or we can import it. So if you have to import it, then where we will go? We will go for, say, open. First we'll press the open, then you will say the data is there, and look, we can find out the where data is there. So as the file type is the SPSS dot SAV, so we have to find out, look, I have just saved it, that practice independent test. Now I will open it. Look, I have opened. Now it is open. Now look, in variable view, say we are having two things. First is group and second is height. This is a numeric. Now width we can change as per, but it doesn't require. We will leave these things as such. Now, so far as decimals are concerned, we will just go on checking. Decimals, we will make it 0, because group is always 1, 2, 3 like that. But height, we have put 2 decimal places. Now, look, group under the major section, what we see that it is ordinal, whereas height is an scale. Because as I have already told you that scale can have any values, so it should be on scale. Now move to the data view. Look, now the data is before us. In first column, it is a group. We are having 2 groups, and their height shown against them. So now if you have to find out, say, the independent t-test, it means, say, 2 groups are there where we are having the data of all the individuals pertaining to their height. Now we have to find out, we wish to find out whether these individuals from group 1 or 2, whether they differ significantly, or there is difference significant between them or not. One more important thing which I would like to say, that look, what do you mean by whether the difference, they differ significantly or not? Whether the difference means to having a difference and that to having a significant difference between group is entirely different. Significant difference means this difference cannot be ignored, whereas a difference without significance can be ignored. For example, say I'm a very plain, very layman term, if I would like to make you people comprehend. Say, if a person can jump uh, 6 meter, 7 meter, he has the capacity to jump 6, 7 meter, and a person is having the capacity of jumping 5 meter. If a person having the capacity of jumping 5 meter can jump up to 7 meter also, then the difference between them, between these two individuals, of course the difference is there, but difference is not significant. Means the difference between these two can be ignored. But if the difference is significant, it means it is statistically significant. We cannot ignore. It means this difference is of pointing in nature. So here, what we do, we are having a group and height. First, what we do, we will go for, again going back, variable who we have entered group and height. Then if you go data view, we are having the data with us. Now we will go look in upper section, what we find that analyze is there, analyze. So we will click it. After clicking, you see there are so many pop-ups are there. Descriptive statistics. So descriptive statistics means what we have learned. Let's go for that. Frequency descriptive. Let's see. Now, what is the variable? Here, height is a variable for us, and group is a factor. Now, okay. Now see what we have with us means total 20 is there, minimum is 4.5, maximum 8.29, mean is 5.793, standard deviation is 9. So this is the descriptive statistics. Let's go again. Descriptive statistics. See here, there are options also there. standard deviation, minimum, maximum, SC, mean, variance, range, everything is there. So you just continue and press OK. Now look, earlier when we haven't selected the standard error, standard deviation, variance, these things were not there. But once we have selected, so we are having range, minimum, maximum, then mean, and the standard deviation and variance is with us. So again, we will close it. Now let's go for independent t-test. See, this is independent t-test, some t-test. Now test variable is there. This is the height. Height is the test variable. So we have put another test variable. What we do, I show you again. We have just select the height and put it under test variable. Now group. Group is another grouping variable. Now look. Sorry. So we haven't defined group here. So we will define the group. So group 1 is, I will put 1, and group 2 as a 2. Now we will continue. Now everything is there. Now option, we will confidence interval 95%. Now we will, yes, okay. Now the result is before us. Now see here, this is the independent sample t-test and group statistics, mean, standard deviation line. What we find out here, look here, the F value is 5.472, and it is significance level, which we are talking about the P value, it is 0.031, means it is less than 0.05. So it means if it is less than 0.05, it means it is a significant. So the difference between these two groups are significant. So this tells us about that. This is called, this is how we calculate independent t-test. Now let's go for the pair t-test. Look again, we are having a practice pair t-test. We will open it. Now look, first we will see that variable view. Look, in variable view, we are having a pre-test and post-test, and both are under the measure under the scales. Now, as I have already filled the data, look, pre-test, these are the values of, say, glucose level of before administering the drug or medicine, and this one is after. So we are having two sets of data from the same subjects. So now we will go for analyze. Under analyzing part, you go for paired sample t-test. So we will have this window open with us. Now paired t-test, this is a pre-test, means the data relating to blood glucose before having the drug. So we have selected it. So variable one, it is a pre-test, and the another is post-test. So these are the two values, two pairs which are with us. Now again we have set the confidence interval. We can set it up to 99, but generally we go for 95. So now we will, okay, now the result is before us. Yes. Look, it is a paired sample t-test. And what is the value? Look, if we go for watching the value, that is the p value, it is 0.000. It means it is highly significant. Highly significant means the medicine which were given to those patients for lowering the glucose level was really working, was having the significant effect on lowering the um, blood glucose level. It was not all due to chance. So this is how the tests are calculated. Now similarly, let's open a file. I have shown you how to open a file, data, then look, practice ANOVA. We will open it. It's with us. Now look. See, here the four groups are there. As we have told, I was told that when we have to compare between two groups, then we go for t-test. But when the number of groups is more than two, and we have to compare all these, then we will go for ANOVA, means analysis of variance. That is one-way ANOVA. In this case, look, there are four groups are there, and this is say hemoglobin concentration. There was one medication, and that was the company was claiming that this is working very nicely, and that was experimented on the four groups. And look, and if you have to find out, then again we will go for analyze. Again, under the compare the means, we will go for one-way ANOVA. Now look, what is the dependent list? So in this case, dependent list is hemoglobin, because it is the hemoglobin whose value is dependent upon the factors, and factor is group. So we have done it. Now contrast, we will put it. We will continue because we have to now look. As we know that in case of pair t-test, independent t-test, single mean t-test, we are having the means, but only two means were there. So we are comparing. But in case of ANOVA, we will having now in this case four means. So comparing them, we must go for some post hoc multiple comparison, and for that these are number of measures are there. But we mostly go for say Tukey's and LSDs. So again, we will go for continue, and options means descriptive statistics that will tell about the mean, the standard error, standard deviation, variance. Again, we will go for continue. Now look. So we are having this descriptives. Four groups were there, and each we are having, which was having 8 numbers. So mean, standard deviation, standard error, the minimum, maximum, lower, upper bound, all these are there. Now this ANOVA table is there. ANOVA means analysis of variance. So between groups and within groups. Look, between groups means it is due to the effect due to treatments, whereas within group means it is due to the differences among the individuals. So what we find that f value is 49, and in case of significance, that is the p value, it is 0.000. It means it is highly significant. So post hoc test means multiple comparison. What we have done, look here, in homogeneous subset, what we find that group 1 and 4, they are under the same column 2, so they don't differ significantly. It means group 1 and 4 are equal, whereas group 2 differs significantly from 1, 4, 3, whereas 3 differs significantly from, but the group 1 and 4 doesn't differ significantly. So this is how the SPSS used, and it is very useful, unlike R. And R is very useful, and we can also do, but that is not user friendly. Means we have to work out. There are some syntax which are used, but we can go for this SPSS because it is graphical user interface is there. So this is how we go for ANOVA, and there are so many case sets also there. We can go for look, correlation, regression, neural networks, multiple responses. So many utilities are there of these. So I think I have covered a little bit of all, and I think I have done with my presentation.
Thank you very much, sir. I think it's very fruitful, practical exercise we have learned, and I think the participants also get benefited from it. and a few of them have some queries. So actually, in between, I have left the meeting due to network connectivity. So I didn't go through the question. So you directly ask from the question, or Dr. Amit, you can see it is there in the chat box. Questions are there.
Okay, let's see. So suppose one sample is of 629, another is of size 45. Tell the sequence of we will do sample image and what test we should use. One sample is of 29, other is of size 45. Actually, it is not Dr. Hemchand is Saikia. He asked a question that suppose one sample size is of 629 and other is of size 45. We want to test the significance of difference between the two sample mean. Of course, if you want to take the two sample mean, then we will go for t-test. But it depends on that whether we will go for the t-test, independent t-test if those samples are independently taken from the different sources. I think only one question is there. Only one question.
Okay. And somebody asked your number also, so you may give directly,
Yes,
or you
yes.
can write in the chat.
Yes, you can provide. Yeah.
So it is very nicely explained and thoroughly observed through these exercise also. So if somebody have some question, they can ask also. So I think there is no more question. So in the end, I would like to thank Dr. Amit for very nicely explaining as well as practically presented all the things what you have taught in the session. So thank you once again for sparing your valuable time for this lecture. Thank you from the Atari as well as Rajmata Sindhya University and NADCL for joining us in today's session. Thank you, one and
Okay.
all. Okay. Okay, sir.
Thank you,
Thank
ma'am. Thank you.
you.
Thank you very much. Okay.
Okay, sir.
Okay.
Thank you.